Can everyone hear me okay? All right, thank you all again for coming. Thank you, Luis, for the introduction. And thank you to Marcos and everyone here at Cinvestav for hosting me. I've had a great trip here so far. This is my first time in Mexico City, and I wish I could stay longer to explore. There's just so much, but I did get a great introduction to your wonderful food last night. I ate so many different animals. I lost count. I had lengua, I had grasshoppers, I had cheeks from beef, I think. It was awesome. So thank you all again for having me and treating me well here. Please, because I do not speak Spanish, if I'm speaking too fast or not clearly enough, just please flag me down and I'll slow down, say things a different way. I just want to make sure we are on the same page there. Also, I'm going to be walking around a lot. I don't like being up here. I feel weird. So I'll go down and move around the crowd, and we'll have you do some work here today too, so it won't be just me talking the whole time. But like Luis said, I do want to tell you a lot about how I teach, and it's not something that I came up with. I didn't come up with the idea of high structure teaching. It is now a growing discipline and field of evidence-based teaching practices that can be applied to any type of discipline. So can we just have a show of hands too? Who here is from the biological sciences? Okay, so most of you. More physical sciences, so physics, chemistry, math. Okay, who am I missing? Is that about it? Engineering, we have engineering here. Great, me too. All right, awesome. Okay, good. So again, we have mostly biologists here, but what we're going to talk about today, even though I'm going to use biology examples, can be applied to the physical sciences, to engineering, and you'll see how that all works, and you'll get to try that out today too. So any good lesson should have objectives in mind. So these are the things that you should be able to do by the end of this colloquium. First, you should be able to explain what high structure course design is. You should be able to describe why high structure course design is beneficial to student learning, discuss best practices for teaching with high structure, and finally develop ideas for implementing principles of high structure course design into your own courses. I also want to tell you a little bit more about me. So Luis did a great introduction, so I'll go quickly here, but I've kind of been all over the place. So these are all the universities I've been a part of. There we go. All throughout the United States. Most recently, I was at UC Irvine. That's where I got to know Marcos, where I did a mentoring workshop. He was part of that. And then I did move to Colorado here last summer. So I've been to the Colorado School of Mines about a year and a half. But I do this to tell you, just again, with Luis's introduction, a little bit about me, but also for the students in the audience, which most of you are the PhD students here, that it's to let you know it's totally okay to kind of bounce around, right? You're going to go around to different maybe careers, different topics, different disciplines. I was chemical engineering, then bioengineering, then biology, and now I'm back to chemical engineering. I've been all across the country. So feel free to not know what you want to do, is kind of what I'm trying to say, and just keep following your path and you'll figure that out along the way. Also, just a little about me too, and the Colorado School of Mines. So this is located in Golden, Colorado. This is our campus here. We're nestled between a couple of Table Mountains. This is our little downtown here, and we like to say we celebrate the West, so it says howdy folks. We are a public research university, and it's very special because we focus almost solely on STEM education, science, technology, engineering, and math. So virtually all of our students, almost 5,000 undergrad and 1,300 graduate students, are all in some kind of engineers. We do have biology programs, chemistry, physics, math, but most of the students are in these applied fields. Also a little bit about me. This is myself and my wife Brittany. We're at the Garden of the Gods park in southern Colorado. And then here are my kids. So if this wants to work, there we go. So this is Teddy. He's 8, and this is Bernie. She's 4. We live up in the mountains in Colorado, about 3,000 meters. And this is one of the first trees we cut down. They did not do it, but they like to think that they did. But we did use that axe. It was very hard. We bought a chainsaw shortly after. This is one of the big reservoirs by our house. That's my wife on a little kayak here. I'm on a kayak taking that picture. We get a lot of outdoors, a lot of snow. We had about 2 feet, almost a meter of snow last week. So it was crazy to get out of there. But really beautiful place. And here's all our chickens too. I've been told by all the students here how much you all like eggs, and we do too. So we have all of our chickens here, Chickaletta, Dr. Grant, many other ones that would give us plenty of eggs. So. Anyways, so what we're going to do today now is kind of three parts. First, I want to talk about what are high structure courses and are they effective. Then I think a big piece of what I want to share today is the idea of assessment. Basically, how do you know if something's working? So I want to share part of a research study that I've done on looking at what are called reading guides and whether they improve student performance in introductory biology. And then lastly, we want to finish putting it back onto you and thinking about how can you use high structure teaching practices in your own courses. Okay, but first we'll talk about what these are and are they effective. All right. So when I first started teaching, I asked myself this question. I've been teaching at the college level for about seven or 8 years now. I asked myself, what's the most effective way to teach? It's a really big question. It can be answered lots of ways, and I'll tell you my answer in a little bit, but first I want to know your answer. So you should have gotten a little sticky note as you walked in the door. So get your little sticky note out. If you don't have one, get a piece of paper, whatever you have on you. And I want you to write down on your sticky note a couple ideas. What's the most effective way to teach? So go ahead, take a minute. Hopefully you have pens. We didn't provide those. But go ahead and jot down what's the most effective way to teach in your mind. So go ahead, take a moment. Use your sticky notes if you have them. Use any other paper you have. Write down a couple thoughts. So this could be from your experiences as a student, from your experiences as an instructor, whatever you think. Write down an idea or two. Okay, it looks like most of you are done, so now what I want you to do is to trade your sticky note at least 3 times. So look behind you, in front of you, side to side. If you want to walk around, that'd be great. Just trade your note, trade it at least 3 times, so you end up with someone who you don't know whose it is. So trade it at least 3 times, move around the room if you need to, pass those notes around, read each other's comments, see if you agree or disagree with what they have to say. See if you agree or disagree. Marcus, were we able to get the microphone? Yeah. Oh, you do have one? Okay, great. 2. We have 2 microphones, perfect. All right, so I'll have them do that next. Okay. Okay. All right. Okay, is this working again? All right, are we all traded a few times? You have someone else's in front of you? Okay, you have someone you don't know. Okay, so we do have a couple of microphones. So Marie, and who else has the other one? The other one. Oh, Luis has one. Okay, so can we get a couple of volunteers to read their sticky notes now? We do have some microphones so we can all hear you. So just raise your hand if you like, and we'll walk around to pass these to you. Read it. This is anonymous now, right? You shouldn't know whose you have, so just read someone else's. What's the most effective way to teach? Don't be shy. It's okay. Volunteers? Oh, over here, Marie. Yeah, we have one over here. Okay, we'll take a couple. So, what does your note say? Yeah.
It says in Spanish, in biology, I think that class would be more effective if it includes experiments in the lab.
Okay, great. So hands-on experience, lab work, real life types of applications. Great. Okay, how about another one? Okay, we have a few back here, Luis. Thank you. Okay.
examples and explaining foundations.
Okay, good. Good foundations, trying things out, fixing them if they don't, more application, great. Okay, I thought we had another hand back here too? Yeah, okay. Hi, thank you.
In my opinion, the most effective way to teach is collaboration with the students first, and then help them to think diversely with some examples. We can show some examples and help them to think diversely, different way.
Great, great. So getting them and collaborating with them, getting the diversity of examples, applications, a whole bunch of different ways to teach. Great, great. One more down here too? Okay, great. Thank you.
I have one that says active learning because students can be stimulated in different areas and improve their abilities so that they can construct concepts.
Great. So that's a perfect transition, active learning there, because you all just did that, right? So what you just did was something that we call a card swap. We had sticky notes, but it still works. So we have you write down your own thoughts first, then you have them pass them around a few times. You get to see other people's thoughts and ideas, and then we report out or share that to the entire group. So I think you know what you just saw in the room. It felt pretty enthusiastic to me. It was loud. There was a positive energy in there. If I would have just asked this question, just asked for hands, we might have gotten some crickets and not many people saying anything, right? So, but because we got you engaged doing something, it kind of enlivens up the classroom and gets more people involved and engaged. So thank you all for sharing your comments on that. And I was right on the same lines as all of you when I was first starting to teach. So I'll go back to the slides now. So what I thought about when I was first asked, when I first started teaching, what's the most effective way to teach? I started looking for evidence. Because I'm trained as an engineer, I'm trained as a scientist, like you all are here too, and we like to use evidence with making our decisions and drawing conclusions and making plans going forward. So I relied on the literature and other resources to figure out what's the most effective way, because I had my own experiences as a student. I had some great teachers, I had some really bad teachers and everything in between. But was that effective or not? Well, this is one foundational book that came out in the late 2000s, about 2009-ish, from Joe Handelsman, who for a while was an education advisor to President Obama in the US. And this really set the foundation for how to teach scientifically. And I'll talk more about that today. We also my postdoctoral program, which was really unique in the United States in that it was not just only working at the bench, only working with cells and animals in research, but rather I got training in how to teach effectively, again, from evidence-based principles. And then also looking at the research literature. There's growing fields in every discipline to do education research, and that's what I do now in biology and engineering. And there's also, therefore, publications and journals that share these results. So this is one such for biology called CBE Life Sciences Education, where as a community we publish articles in our research on the best ways to teach and student learning in biology. So by kind of taking all these experience and resources together, the evidence from research in my training, I decided that high structure course design, what we'll talk about today, and active learning were based on the evidence, some of the best and most effective ways to teach. And again, we'll work through some more examples of these today. Again, these are from my training, from evidence I looked at, but these are also broader calls from the United States perspective. A report called Vision and Change came from our National Science Foundation, and it addressed how we should be teaching biology in the 21st century. It should not be just a list of facts. It should not be primarily lecture or didactic teaching. It should be more engagement, application, hands-on lab experiences, things like that. Also from President Obama's group came a report called Engage to Excel, and it looked at how we can train our university graduates in the US more effectively by changing our teaching practices. And then from an engineering perspective, the Transforming Undergraduate Education Engineering reports came out. And this also provided guidelines for how to more effectively teach, including this quote. So they asked a bunch of students, engineering students, how should they be taught? And here's what one of them said. So actually make it required for professors to learn how to teach. In the United States, there is no training required. If you have a PhD, you can go join a university and they'll throw you in a class with 300 students, right? So this comment is getting at the point that, well, maybe us as faculty should get some training in what we're doing, right? Because a large part of our job is teaching. So there's these national calls for this. A lot of it focuses on active learning as well, which we already demonstrated. We had you involved with that activity. A formal definition for this can be such as this. So active learning is a method of instruction where students are actively participating in the learning process with activities such as what we just did, problem solving, case studies, group work, something called team-based learning. And all of this is, again, you're actively involved. So it's the opposite of what you're doing right now, which is listening to me talk. Okay, so that's the opposite of a primarily learning through didactic or passive lecture. So again, it's the active. So what we try to do with active learning is go away from this, which again, kind of looks like what's happening right now. You're sitting here politely and listening to me, and more like this, right? So you see these students here, they're talking to each other, you can see in the background, they're pointing at the screen, discussing a problem. They have devices in front of them. These are called clickers. These are very commonly used in the US to get student responses during a classroom. We're going to practice that today too. So they're much more engaged in the classroom. And here's me in one of my active learning classrooms at UC Irvine. So it's a little bit bigger than this room. It held about 450 students. And there I am there and amongst the sea of students. And if you all remember last year at this time, you had Diane O'Dowd out from UC Irvine. That's one of her graduate students, Alexa. So she was one of my TAs for the class. And she's been continuing on Diane's work at UC Irvine. So again, you can do this type of teaching, active learning, with as small as a few students or as big as I did it with 440. And I know people that do it with 800 at even larger universities. So it's again all about just getting students to be doing stuff in the classroom rather than engaged primarily through passive lecture. I should have said at the beginning, but I'll stop now. If you have questions or comments as we're going, please stop me, raise your hand, shout me down, and we can take questions. But this might be a good time just to pause if there are any up to this point. Okay, all right, so save them to the end, that's fine too. All right. So again, active learning, it sounds cool, it's fun, you guys did it, you were engaged, I heard some laughs even, right, you were getting into it. But there, again, there's evidence that shows that this is effective. So this came from our proceedings for the National Academy of Sciences. It's one of our premier journals in the US. And it published this paper on active learning across all of STEM, science, engineering, technology, and math. And what they found was, and this was what's called a meta-analysis, so it looked at several hundred individual studies on active learning. They found that when active learning was used in a classroom, they found that the failure rate actually decreased. So if you use active learning in a classroom, the number of students, the proportion of students who failed that course went down. And that's what should be a goal, I would think, of us as instructors, to not have as many students fail. They also looked at this, and this was everything lumped together. They then broke it down, by STEM discipline, and they looked at what's called Hedges G, which is a kind of an effect size calculation, saying what's the effect that you're getting for the treatment. And what they found was in every single discipline, here's the overall average here, but you can find your discipline here if you'd like, there was a positive effect for using active learning contrasted to, again, more passive lecture-based courses. So this is what's going on in the classroom. We're having students engage through activities, problem solving, group work, etc. And just by doing that, just by flipping that little bit, instead of the passive content delivery, you're able to see decreased failure rates and positive effects on exam scores through having students engaged in the classroom. I'm not trying to tell you that lecture is bad. Please don't take that as a message. But what I might say is that all lecture is bad. So if the entire class, 90 minutes, is just lecture, we can do some changes there. But if you're doing active learning, you're not going to have one activity for 90 minutes straight. Of course, there's going to be lecture during the class to deliver content, to explain concepts, clarify misconceptions. And it's going to be up to you as the individual to find your kind of niche, to find what works best for you. And I'll talk on that point more later on. Okay. All right, so that's showing active learning is beneficial and is big overall assessment. This was a paper, again in PNS, that just came out in September that's really interesting because it looked at students, how they felt about how they're learning versus how they actually did learn. So this was done at Harvard, and they looked at a statics class, so a physics type course on statics, and they asked students at the end of the course how much they enjoyed the class. Did they learn a lot from that lecture? The instructor was effective. I wish all my physics courses were taught this way. And they taught the courses two different ways, the lectures two different ways. One was more passive, so just talking, content delivery, whereas the other in black was active, so the activity-based classroom. So as you see here, in every category, the students felt like they did better and had higher enjoyment in the more passive lecture. But they also gave them a test at the end of that class period. So, and here's what they found. It was actually opposite now. The students who had the activities in class, who did the active learning, scored higher on that test of learning, on that statics lesson, compared to students who had the passive reception of the lecture. So even though students might think they like lecture more, they actually do better with active learning-based classes, which is an interesting finding. One of the tips I'll give you at the end is to provide evidence for why you're doing things the way you do in the classroom if you decide to adopt these types of pedagogies. This is a great piece of evidence to show your students. Yes, you might not like active learning as much, you might think it's not as effective, but you actually do better. And students, as you all know here, you all care about grades, so showing that you're doing better is probably a good piece of evidence to explain why you're teaching the way you are. Okay, so however, that's what happens in the classroom. That's active learning. But you only have your students for maybe 3 hours a week, maybe 4 hours, maybe 5 if it's a lab course. There's a lot of other time where they could be doing stuff. So in my opinion, and others as well in our fields, we think it's just as important to consider what happens before class and after class as to what happens during class. So yes, active learning works. It helps improve the in-class experience, helps improve performance. But again, what about before class? What about after class? So I want you to brainstorm with each other again now. So go ahead and talk to those around you. What can you do before a class period or after a class period to help students learn? What types of activities, assignments, extracurricular things, whatever you can think of. Go ahead and brainstorm. Go ahead and talk to each other again. I'll take a break from talking. Go ahead and discuss. What can you do before and after class to help students learn? Time, when are we done? 1:30, right? All right, let's ask Marcos. Okay, I think that's what it was. I just don't want to go long. Okay, all right, just, I don't want to. An hour. Okay, all right, so just maybe I'll keep track of time, but if you want me to hurry up, just go like that. 1:30, okay, that should be fine. Okay. Okay, all right. Okay, so let's again get some comments from the group. Again, microphones are ready if you would like to volunteer. What did you discuss? What can you do before class or after class to help students with their learning? See, you don't want to stop talking. This active learning stuff is great. All right, so but now though, let's quiet down so we can hear a response here. Oh yeah, sorry, can we quiet down real quick, everyone? Thank you. Okay, go ahead, get it in.
In both cases, you could do an outlook, what will you learn in that class, and after the class ended, you could take a look back of what did you learn.
Okay, so after the class, reflect back on what happened, try to assess yourself and what you learned and what you still might be struggling with. Great, great. Okay, others? Okay. Way in the back again. Okay. If anyone's in between, though, raise your hand. We'll get you on the way.
before class, in my opinion, I would like to make a plan. What I'm going to discuss, what I'm going to teach, and when I'm going to finish. And then after, gather the information before everything before class, and after the class, evaluate how was the how many people can affected in my class, and how can I improve again. That is what I want to do.
Great. So you as the instructor need to plan ahead for what's going to happen that day, and then also reflect back on how it went, right? Did things go as planned? Did I cover everything? Did the learning occur as I thought they would? What about some things you might have the students do? I'll just ask for a show of hands now. Have any of you had to do homework after class? Anybody ever had to do homework after class? Really? Not a whole lot. Okay, okay. Anyone, do you have another comment to share? Okay, good. We'll have another comment down here. Okay. Oh, either one.
Yeah, we were discussing about make some activities before the class, see some videos or check some activities before the class.
Great.
About the topic, but it's important to know for the students what is the topic of the next class.
Mm-hmm.
And then after the class, it's important to have a kind of evidence or evaluation. So it's important to have a report. We were talking about physics, maths, and chemistry. Some activities on problems to solve or interchange problems between one team to other team, and then qualify the other team. And at the end, as a professor, we need to check everything is fine. It's a kind of activity to have the part of the teacher, but also the student.
Great, great. Yeah, so have them do some kind of content acquisition before class, reading the book, watching videos. Has anyone ever been asked to read the book before class? All right. Now keep your hands up for a second if you've been asked that. Now, how many of you actually did the reading? All right, a lot of hands are going down. Okay, okay. I'm going to talk about that later on, right? But you can have students do stuff before to get some of the content before class starts, and then you can assess them afterwards, right? So some type of evaluative assignment, whether it's trading group problems, which is a great idea, lots of different things you can do. So you can structure your course in a way to help the learning happening before and after class, in addition to during. And that's the idea of a high structure course. So what is a high structure course? So in the literature and in our field, we define it as a course that includes some kind of graded pre-class assignment. So you have to give some benefit to doing the pre-class work, so a grade. In-class active learning exercises, and then some kind of after-class review assignment that's also graded. That could be a quiz, it could be a homework set, all sorts of different things. This can be, with this in mind, then you can classify a course, and sorry, this is a little small, you can classify a course as low structure, which would be traditional lecture. So that's a course that basically is very little active learning, if any, more content delivery, maybe a homework, maybe not. Moderate structure, meaning it has some active learning, but it also has one or the other, pre-class or post-class work. And then a high structure course that would have pre-class assignments and after-class assignments that are graded in addition to the in-class active learning. So that would be a high structure course. And why we do this? Well, it works. So why do we teach with high structure? From the literature, again, there's been many benefits shown. First one is that content delivery is moved before class. So if I only have you for 50 minutes to discuss a concept for the day, if I have to tell you all about it for the first time, that really limits what else I can do in the class. It limits my ability to have you do, solve problems, to do practice questions, to design experiments, to actually do experiments. So if you move content delivery before class through videos or reading, you have more time in class to do other stuff that's more fun, more engaging. So that class time then is freed up for active learning, which we already showed is beneficial, and also for what's called higher level Bloom's activities. Bloom's taxonomy is a level of cognition or thinking, from the lowest, just basic memorization, to the highest evaluation and synthesis of new ideas. So if you get more time in class, you can have students practice higher level skills. There's also been evidence that students feel more belonging in the class. Belonging is a measure of how many friends are you making, how connected you feel to each other as well to your university. So by having this type of class structure with the active learning, students actually have more positive feelings about working with each other and for their own institution. And then lastly, going back to performance, students do perform better. So this was published in the journal Science. So Science does sometimes publish education stuff, which is exciting. And in this case, they showed that course structure also decreases failure rates. Another thing that structure has been shown to do is close achievement gaps. So an achievement gap is something that exists between different groups or populations of students. So a common one in STEM fields is a gender gap, where in some fields, maybe physics, it's been shown males outperform females. In the United States, we have an ethnicity gender gap between black and white students. We also have a generation gap, which means students going to college they're the first person in their family to go to college, they're a first generation college student, versus a continuing generation college student, that's someone who's at least one of their parents has gone to college. And in both cases here, what you see when you increase the structure of a course, this is for an introductory biology course, you see those gaps get smaller. So structure can help all students do better, higher structure can help all students do better, but it can also help close some of these gaps to help certain groups of students do better than they might otherwise do. So there's a lot of benefits for teaching with high structure that I think, again, tell your students why you're doing it. Show them evidence, and this is one of them here. All right, so I want to tell you a little bit about my high structure courses now, and then transition to a little bit about assessment in my research that I do. So I teach at the Colorado School of Mines, again in chemical and biological engineering, and I teach on both sides of that discipline. So I teach both in biology and in chemical engineering. So within traditional biology courses, I teach introductory biology, and I also teach anatomy and physiology, which today's our last day of class, and I'm missing both of those. But they're okay, my students will be okay, they're in good hands. And then I also teach in chemical engineering. So I teach what's called material and energy balances. This is our sophomore level kind of core chemical engineering course. And I also teach introductory thermodynamics. So it makes some really fun days doing all these different courses, but I apply the same model of high structure to all of them. And through over the years, my research then is focused on developing, implementing, and assessing components of high structure courses. And that's what I really want to talk about now is the assessment piece. Because sometimes just doing it isn't enough. You need to know if it's working. So let's say you're using high structure in an intro bio course, in an ecology course, in a chemistry course, whatever. So let's say you're using high structure, you're using active learning, you have these graded pre-class assignments, after-class assignments, etc. How do you know if it's working though? How do you know if it's working or not? Discuss, chat with each other again. How do you know if it's actually working? Go ahead and discuss. Yes, sir.
Evaluation.
Question?
Evaluation.
Oh, evaluation. Yes, but what kind? Yeah.
About the subject.
Oh, so like some kind of test or some type of thing like that? Yep. That's definitely a good one. Yeah, I will let you know. Yep, good. Okay, I'll stop you there again. So can we get some more volunteers? Just a couple ideas. What might you do to know if it's working or not? So a couple hands would be great again. Oh, we have a hand over there, Luis? Luis got that one. Okay, all right. So how do you know if it's working?
We were discussing that, for example, she used to give classes in Congress, and she says that with her students,
But how do you know that they remembered something? Like, what did you actually do, or how did you know that?
Because she discusses with them
Okay.
about that thing. And for example, she says that when it's something boring, and she asks them, do you remember what we saw yesterday? They say, I don't even remember what I ate yesterday.
Okay.
But when they are actually learning or active learning, they say, yeah, I remember some of it, maybe the main parts of it.
Okay, great. So through discussions, you're able to get an idea if they're remembering or learning or not. Great. Yeah, so student feedback is definitely a big one. Any other ideas you talked about?
Yeah, definitely we need to have a way
Uh-oh.
to evaluate the students.
Mhm.
So in your case, you have 400 or more than 500 students. It's really difficult to evaluate after each class, and it's important to use some specific tools. Nowadays, we have cell phones or other tools that we can use, and there are a lot of different applications. And even if we don't have access to that special tools, we can improve or implement something in the classroom to have the feedback instantly from the students.
Great. So you can get that instant feedback in class through some type of assessment. So you talk about use of technology. So we're going to practice that here in a minute, but you can use these clicker devices, you can use cell phones for that to get real-time assessment of, do you know the answer to this question or not? Is this working or not? You can also do that more of like what we say an analog format. So you could just have them hold up hands or a note card with something written on it, right? So there's ways to do it without the tech too. But yeah, getting some kind of immediate feedback from them is a great way. Yes?
Another way to get feedback is by quiz or exam or evaluation.
Great. Yeah, so just a more traditional examination or quiz, and you can do that on a weekly basis, a bigger exam, maybe after a big unit in the course, a midterm or a final, and you could, again, get a feel if what you're doing is working or not. So I think those all hit the same right things I wanted to discuss. You can get that immediate feedback in class through either student discussion and opportunity or through actual assessment with clickers or other types of devices, or again, these bigger assessments, what we call summative assessments, can also help you figure out if it's working or not. But again, the idea is you need to assess it. Just doing it again, you might have a good feel for your class, right? You can kind of read the energy of the room and kind of get a sense of, oh, that didn't go well, or oh, that was awesome. And when I had 400 students, or I like to think of it as 800 eyeballs looking at me, when things didn't work, you could feel that, So you get that gut feeling, but you want better evidence than that. You want some data. So later today, those of you in the workshop, the grad students, we're going to do a workshop on getting started in research, discipline-based education research after lunch today. So I'm looking forward to working with you on that. And those of you that can't attend, if you're interested in learning more, I'd be happy to share you the materials I'll have for later today. Okay, let me tell you and show you now about one of my own projects on assessing high-structure courses and how I went about doing it. So again, collecting data on how your course teaching and student learning are going is a critical part of assessment and how you know if something works or not. If you're in your lab working with your cell line, your animals, your chemistry, whatever you're studying, you're not going to just use a gut feeling to see if that drug is working, right? You're going to collect data. We do the same thing with education. So here's some data that I collected from a student survey. So at the end of a course, and this is summarizing 2 courses. This is for an introductory biology course and a human anatomy course at UC Irvine. I asked students, what component in the class did you value the most? So in other words, what was the most useful part of the class in terms of learning the material? And I forced them to pick just one option. And here were the options I gave them. Reading the textbook by itself, textbook alone, reading the textbook and doing these reading guides, which I mentioned briefly, but I'm going to talk more about next. These are just Word documents with a series of questions for them to answer while they read, so it gets them actively engaged in reading. Actually coming to class with me, right, the in-class lesson. Is that the most valuable? I use frequent online assignments to do that pre-class work and after-class quizzing. We use online tools for that. And then finally, coming to your discussion section, which is a smaller group of maybe 30 students, or your lab section in anatomy. So those were the 5 options I gave them, and I want you to think about it and also now tell me and vote with this. So we're going to use a piece of software called Poll Everywhere. So this is going to allow you to use your smartphones or text to answer this question. So I'm going to go over to that now. All right, and I'll turn this on. So what you need to do here is go to, if you want to use a browser on your phone, you can go to polev.com/this link, and then you'll click in an answer. If you want to text, you can do that too. You're going to text this to this number, and then you'll click in an answer. So go ahead and click in when you're ready. Again, go on your phones to this website, and you'll pick an answer, or you can text it in. Just so you know, I'm using the free version of this software, so it's limited to 40 results. So whoever's fastest gets their answers on the screen. So go ahead and try it out. Oh, we got someone in already. You can see the number of results trickling in down here. So this is very similar to something I would do in class. Maybe instead I'd be asking a question about meiosis or genetic inheritance, and you can click in or tell me your answers in real time. So go ahead and try that out. As you're clicking in, go ahead and discuss with each other what you think they voted as the most useful part was and why. So go ahead and discuss that as you're sending in your results. And we're almost there to 40, so we'll have to finish that up soon. Almost there. We got one more. Who's going to get it? There we are. All right. Okay, so let's take a look now and see what you said. Okay, so let's show you. All right, so there's what you said. So again, this was just the first 40 of you that clicked in. I'm assuming it's representative of the group. So you had almost half of you thought it was that smaller discussion or lab section was most valuable. Then a quarter was for me, like lessons in class, a little bit for the online, then much lower for the textbooks. So let me show you what they actually said though. So you were all pretty wrong. That's okay. All right. So it was the textbook plus these reading guides, right? So when I first saw these data, I'm like, huh, they really like reading and they really like these reading guides. But then I looked over here. That's me. That's class, right? So I thought, what am I doing wrong? But then I thought, wait a minute. This is one of the goals of high structure, right? We want to move a lot of that content acquisition before class. Do the reading. Do what are called reading guides, which I'll show you next. And then in class is really just practice and clarification and explanation. It's no longer content delivery. So when they're saying learning just the basic material, they're doing this on their own through the reading and the reading guides. And so this led me to now a question. So first of all, like I had students coming up to me and saying, oh, these reading guides are great. They really help me learn. I'm like, okay, great, but you just told me that. I don't really believe it. And now I have some survey data showing, well, that overwhelmingly, for this intro bio class, this green bar, this is like 500 plus students saying this, right? This is a lot of students. So I'm thinking, okay, well maybe there's something to this. But now the next question is to actually assess it, right? So I wanted to know how effective are the components of a high structure course. So let's now bring this classroom setting, this kind of gut feeling, some minimal survey data, and let's bring it to a scientific perspective. Let's rigorously assess this question as you would assess your cells in your own lab, for example. So that's going to go to this next part here, talking about assessing a high structure course and figuring out, do these pre-class reading guides actually improve student performance in intro bio? So at this point, I'll put on my researcher hat and I'll give a traditional research part of the talk and just talk through it. But we'll come back to more active learning here at the end with you all. So the question again is, do these pre-class reading guides improve student performance in intro bio? Sometimes this happens with reading, right? We don't want that. We want something more like this. Someone's happy, engaged, they have really white teeth, they're doing a great job taking notes while they're reading, right? I had great help at Irvine with 3 students, Rebecca, Anahita, and Ashley, who worked on this project with me. So they're authors on this paper. I want to recognize their contributions here. So the first question, though, to figure out before they work, do students actually read? Right? You saw your hands go down when they actually do the reading. So we want to know, do students actually read their textbook? So from the literature in physics, a study found about 41% from surveys, students regularly read their books. In psychology, it goes down to 27%. And then finance students, it was 8%. But they're obviously the smart ones because they're making the most money, right? The finance students. So they don't need to read, I guess. But anyway, so it's kind of bleak. It's not a great picture. But are there things that we can do to encourage students to read their books? Well, there's been quite a few interventions tested over the years. One is called the Daily Dozen, and this was just a list of questions, kind of like a reading guide that I'm going to show you, that students were given to complete. Write them down, write down your answers before you came to class to do active learning in intro bio. That was shown to be effective. We've also seen pre-class quizzes pointing to specific figures. So if you have an online quiz that says, hey, read the book, look at figure 6.3, answer this question, that got up to 80% of the class reading their textbook. That was for bio and for physics. There was a study guide that was helpful for teaching social work students in a certain course setting, and then also for computer science. They called these exploratory homeworks. These were used to help students learning to code as they're reading. So they're reading a book about coding, but they're actually coding at the same time, and that helped them learn overall. So these types of things have been effective, but what I wanted to do is put my spin on it for an active learning, high-structure introductory biology course. So what are these reading guides that I'm talking about? I'll actually show them to you in a second. So these are just Word documents that accompany the textbook. So we use Campbell Biology. It's a very traditional introductory biology book. And I made these Word documents that have a series of questions and things for them to do while they're reading. There was about one per day of class, and they ranged in length from 2 to 5 pages, and they averaged about 3.5 pages. We had 24 days of class in this course that I'm going to discuss. These were just totally optional. They weren't graded. The students didn't turn them in. I did this with over 800 students. They had 2 sections of 400 plus each, so we didn't have the capacity to actually look at them and grade them. So they were just optional. We told them, you should use these. They'll help you. So we were strongly encouraged students to do these before they did their online graded assignment. So we use a system called Mastering Biology. It provides a way to do online assignments that are automatically graded. So this helps students test themselves after they do the reading. I never posted the completed version, so if they wanted to do it or wanted the answers, they'd either have to do it on their own or get it from a friend. And then the big thing with this was focusing on accountability, telling them, if you do these, if you read and do your reading guide, you're going to do better in your pre-class homework, you're going to be able to contribute more in class, you're going to be able to hopefully do better on exams. But I didn't know that the first time I used them. So again, we wanted to test them and assess them, see if they actually worked. So what is in a reading guide? We're trying to get students to convert from doing this, which you might have seen this in a book before, just highlighting every single word. We don't want that. Instead, I want something like this. So this is a little small, I apologize, but this says, redraw figure 13.4 in the space below. This will help you distinguish between sister chromatids and homologous chromosomes. Describe the human life cycle using these terms. I don't want you to read this section, so I'm telling you to skip it. Right? Here it says, use a figure to complete this table summarizing the steps of meiosis 1 and 2. So what this allows me to do through these different types of assignments or different types of questions, defining terms, summarizing concepts, tables, drawings, referencing specific passages, this allows me to be completely transparent with my students so they know what I want them to know. I've had way too many classes in my day where the instructor said, read chapter 7. But in their mind, they didn't really want you to read everything. They're not going to cover everything, but it's easy to say that. So instead, this makes it very specific what they should know. I like to say to my students, I want to know what you know, not what you think I want you to know. And this is one level to help with that transparency to make sure we're on the same page. So this is what we're trying to get them to do. But again, are they effective? Students came up and told me about it. I had that survey data that said that, but are they really effective? Let's test this. Let's study this scientifically. So what I did at the beginning of each day of class, because there was one reading guide for each day of class, I had them do a clicker question, kind of like we did with that poll everywhere, vote on your phone. I had them click in and tell me this answer. So basically, how did you prepare for class today? You did the entire reading guide? I did more than half, but not all of it. Less than half of it. I didn't do it at all, but I still read the book. And then at E's, I didn't do anything. So I had them self-report to me. How much did you prepare for class that day? And here's what I saw. I want to show you some of the distributions as the class went on. So on the first day of class, first week of class, we had a 2-page reading guide about the scientific method. 73% of the class, this is over 300 students, did the entire thing. That's great. But now, let's move on to middle of this course when there's other stuff going on, other midterms, other courses. This was a 5-page reading guide about cellular respiration in week 4. we're down to 35% doing the whole thing. But we had 29% doing at least half of it. That was still good. And then if we go to the end of the course, week 10, this was on the quarter system, a 10-week class, we had a 5-page reading guide about neurons. Then we went back up to 45% doing the whole thing. So it kind of ebbed and flowed throughout the quarter. But what we found overall was that on a given day, at least 75% or more students did at least something. So that at least 75% of students are reading some of the book. They're doing at least some of the reading guide. That number, I know, would be much smaller if we didn't have any type of guide to help them with the reading. But this helps them navigate the textbook, understand what they need to know. So that was good to see. So they're doing the reading, they're doing the reading guide, but is it helping? That's what we need to know. But first we had to know, can we actually trust their data, right? So we had these data here, but I don't know if they actually did it, right? They didn't turn it in. I didn't go around to all 400 students and look at theirs. So on the last day of class, I asked them this question now. So how honest have you been with answering that question? Right? So, and you can see the distribution there. So we had some, but how do I trust this one, right? Which one are they lying about? I don't know. So what we did then, I had our graduate student TAs, so I couldn't have done this without them, so thanks to all of you who have served as TAs in your days. Are these 65% really being honest? So what we did was we went to the discussion section. So these are the smaller groups of 30 students. And we actually had the graduate student TAs randomly look at them. We said, okay, pull out your reading guides. I'm going to walk around. And they did a little check mark. Oh, this person did the whole thing. You did half of it. You did none of it, right? You did a check mark. And then we compared those reading guide visual completion rates with their clicker question answers. And we actually got 69% agreed with what they said in class to me. I think that's just a coincidence, 69%, 65%, but maybe that they are really being honest in that question, I don't know. But this was some way to help validate the data. That's a problem with self-report data in education research is that, well, are you telling the truth here? There's something called social conformity theory, where you might respond a certain way because you know your peers or your instructor wants you to respond a certain way. So, you know, those people that said A to these might have artificially been inflated, but this was a way to double check that. And in my mind, this was a good way to do that and a valid way to check the data. So we're gonna move forward then with these data and say, okay, we know how often they completed the reading guides, but do they help? So does the reading guide completion help exam performance? And I'm going to make this very specific in that does reading guide completion prior to class contribute to exam performance? So what I did was we counted up how many times they answered A. So basically how many reading guides did they do the entire thing for? And we had 6 lessons per an exam. So their answer there could be 0 to 6. And then using R, I did multiple linear regression, which controls for a bunch of demographic factors, including your ethnicity, gender, aptitude based on SAT scores, what section of the course you were in, all these different things. And this allows you to make a more accurate characterization of how many reading guides you did actually contributed to your exam score. So this, I'm not going to show you the entire model output, I'm just going to summarize it for you. But basically what I found was that for each of we had 4 exams that course, 3 midterms and a final. And for each exam, for every reading guide you did, we saw a positive effect. Meaning that when, for one reading guide, this is the effect you would get, the bump or increase you get on an exam score for every reading guide that you did, just for one of them. So for one reading guide, we saw with the errors here, anywhere from 1 to 2% increase in an exam score. And remember, we had 6 lessons per exam. So if you did all 6 reading guides for a single exam, multiply this by 6, that gave you a 6 to 12% increase in exam score, which is anywhere from a plus-minus letter grade to a whole letter grade, B to an A improvement. And that's just for being proactive, for staying on task, reading the book, helping fill out these reading guides as you read. So this was really exciting to me now that I could then go back to my students the next time I taught the course and say, hey, look, these things actually do help. This is controlling for aptitude, for ethnicity, for gender, for other effects, right? These are doing something. There's some effect here. We're able to measure that. So that was really exciting to see that what started out with some students telling me, yeah, these things are great. They help me. Then I saw that survey question. A lot of students said they were helpful. Here's some actual data from performance showing that they do help, right? So this is kind of the transition of what could be a research study, showing you from just some initial observation, testing a hypothesis, carrying through the experiment, analyzing the data to draw conclusions, just like you would do in your research lab. So assessment, again, is really, really important here for looking at your high structure or active learning classrooms. But now, let's finish up here in the last few minutes, putting it back on you. So how can you use high structure and active learning in your own courses? To first get this idea, I want to ask you another poll everywhere question, and this time you're going to get to type things into your box. You're going to get to text it in however you like. So before you actually do this thing, you're probably all thinking, well, how am I actually going to do that, right? How am I going to add active learning? How am I going to have these assignments? How am I going to use clickers? All these things. So I want you to click here on poll everywhere and tell me now, what are the biggest challenges with what do you think the biggest challenges are with adopting high structure teaching practices in your own courses? So again, you can go to that same website. You can try this out. You can text it in however you'd like, but you'll be able to here now send in some text. You can do a sentence, a couple words, whatever you'd like. But tell me, what are the biggest challenges with adopting high structure teaching practices in your own courses? And we will let them come up so they're going to come up as you click in. So this one said time. That was our first answer. So you can see them come up here. So again, we were limited to 40, but let's take a look at your biggest challenges about adopting these practices. Blame the students, okay. All right. Time again. Time is a big one, for sure. Right, so student engagement's a big one, right? Right, do the students have the time to do this? Where do you get ideas to do it? Right, your motivation's important, great. Getting the students to participate can be difficult, yeah. It does take a lot of work, but it's worth it. That's a huge one. Their mood does matter. Yeah. So as you keep, yeah, it happens. There's actually journal articles written about how to fight student resistance to active learning. The way I do it is just, again, explain to them why we're doing the things we're doing, and then just keep doing it. Don't give up. Make it normal. Okay. That is a big concern in the United States as well. If students do not have access to the technology, you can't do some of these online assignments, but you can craft them to do them written or take home in other ways. But that is definitely something to think about. Okay. Great. Okay, so we'll let a few more come in here. Oh, there's a big one. Okay, let's read it. Yeah, so it could be distractions for all this stuff working, and again considering the technology for doing this. So one of the biggest reasons and challenges that people have given from the faculty perspective, one is time, right? How do you have time to do all this? Two is, what's the incentive? In most universities, the incentive for a professor to do well, to move on, to get tenure and be promoted is usually based on your research productivity, right? How many papers did you publish? How many grant dollars did you bring in? How many students do you train? Teaching is often just a small part of that. I'm a teaching professor at Mines, and I was at Irvine, so my evaluation for tenure and promotion, it's much more weighted on teaching. But for a traditional research faculty, your teaching part's going to be most likely smaller. So what's the incentive to do these types of things, right? You have to think about that. What's the reason to make changes to add this? So the incentive structure and time are the two real biggest reasons or challenges for what would be coming up to adopt these things. I do want to give you some tips here to end, to wrap up here in a couple minutes. So I just want to, lastly, to finish up here. We won't do this just for time's sake, but I want you to leave today with a challenge to yourself that if you got excited about any of this type of teaching, and we demonstrated a lot of this in class, right? We did discussing with your neighbors, we did reporting out to the whole group, we did the card swap, We did the poll everywhere clicker type question. We did a free response type question where you clicked in your answer, writing out sentences or words. Right? If you got excited about using any of these, I want you to try them out next time you teach your classes. Next time you're doing a big class, small class, whatever, try them out. And I'll leave you with some tips for this now. Okay, so some tips for trying to adopt these types of practices. The first one, be confident. Okay, don't go into it thinking it's not going to work, which it might not work, but don't think that. And more importantly, don't let your students know that. Okay. So one of the worst things I saw, unfortunately, was a faculty member at another university he used to work at. I was observing him teach, and he had never done active learning before. He got up in front of the class and he said, you know what, everyone, today we're going to try this active learning thing. I'm not sure if it's going to work or not, but we're going to do it anyways. It sucked after that, right? Just because the students you can read, you guys can do that, right? People can read each other. If you can see someone, if they're not confident in what's going to happen, it might not go well, right? So be confident. You fake it till you make it, as we say, right? So you got to be confident about it. Start small. What I showed you was a lot of stuff, and a lot of you said, time, how do I do all this? Those are the challenges. But start small. You could take an existing class that is primarily lecture-based and do one tiny thing will make a huge difference. So say you're normally asking a question to the class. You ask a question to everyone. Can someone tell me about the difference between, going back to that example, the difference between sister chromatids and homologous chromosomes? You ask the entire class. No one says anything. Then you answer your own question. That sometimes happens, right? So if you ask a question to the whole class and you don't get any responses, just say, okay, turn to who's sitting next to you. Turn to your neighbor. Talk about it for 30 seconds. They might be, what are you doing? But you do it, and they talk to each other, and then you ask again, okay, now who can tell me? You're going to get more responses. That's one change you can make. Requires zero investment of time or energy. You do it on the fly, and that can actually have a huge impact on the attitude, enthusiasm, energy level in the room. So try little things first. Start small. If you want to add the pre-class assignments, the clickers, the review assignments, maybe you pick one at a time for an existing course, right? Do one this semester, one the next. You can slowly add on there. And while you're doing that, assess it. Again, explain to your students why you're teaching this way. Let them know why things are going the way they're going, why you're doing this. Tell them you didn't create this method just to give them busy work. We have evidence showing it's going to help you learn. It's going to help you feel better. It's going to make you feel more like a part of the group, right? And show them the evidence, why you're teaching this way. A really important part, use the techniques that feel right and fit with your personality and teaching style. There are so many ways to teach actively and to add structure, but do what feels right to you. Notice I walked around a little bit while you were talking to each other. I didn't lean in and say, oh, Marcos, can you tell me what you're thinking? I just walk around and listen. And that's not my style to lean in and ask individual questions on smaller scales. But some people really like that, right? So do what fits your style. If it doesn't feel right, don't try it. Don't force it. Don't reinvent the wheel, right? Use existing resources and adopt them for your own course. Whether you're in chemistry, biology, engineering, math, physics, there's a ton of stuff already online. Use those materials before you try to come up with them on your own. But you might want to adapt them for your own purposes. And then again, assessment, figuring out what's working, figuring out what's not working. Assess it. It's a cycle. Figure out and change, make improvements going forward. And again, be enthusiastic about it. If you try it and it works, share it with your colleagues. Try to get your other faculty members, your other fellow teaching assistants excited about it. Have them come see you teach. The best way to learn how to teach is to see other people teach. That's what I did all through my career. I still do it to this day. I go to new people's classrooms. I see what they're doing. I learn new things every single time. So if you want to try to share your experiences, invite one of your colleagues or classmates or peers to your classroom. Let them see what you're doing. Maybe they'll get excited to try things too. Okay. All right, with that, I just want to thank quite a few people here. Some of my new colleagues at Mines, my undergraduate students, Jordan Lopez is my current student at Mines, as well as several faculty at UC Irvine who got me supported in all of this work, and even going back to Carolina, who started helping me with my teaching, development, and education research plan. So I would not be here with all of them, definitely not. So I can't thank them all enough, and I can't thank you all enough for your time and attention and energy today. So thank you all. Marcus, I don't know how much time we have, but I'd be happy to answer any questions you all have. Yeah. So we have the microphones again if you want to walk around we can answer questions. If you got to head out to the next thing, I totally understand, not a problem. Yeah.
Do you think this type of techniques could be applied to graduate classes? Because there is like this stigma that when you're in a graduate school, you should learn everything by yourself and not rely very much on the teachers.
So can this be applied to graduate school? Is that the question? Yeah, of course, absolutely, right? I mean, one of the big things you're trying to learn as PhD students is how to read the literature, how to analyze data, how to design experiments, right? You can be doing all that ahead of time, right? So if you're going to have a discussion on a primary literature article, have your students read it beforehand, but maybe give them a few questions to answer as they're reading. You know, pay attention to this figure. Why did they use this technique? Or why did they use this statistical method to analyze it, right? That will help you become more prepared for the class where you actually discuss that paper then, right? So easily can be applied to graduate school. I agree at the graduate level, we would expect our students to be more independent, more motivated, more able to maybe learn on their own. But there's nothing wrong at all, I think, with helping them develop that skill set again through some type of structure, whether it's before class or in class or group discussions or other type of group projects to get them more involved. So yeah, totally can be applied. Yeah. Yeah.
So in Mexico, I think around half of the population is below some level of poverty line. How would you address the lack of technology when you try to teach?
Yep. Oh, I totally understand that. The comment was that in Mexico, about half the country is below the poverty line. So there's quite a few free educational resources available now. So you can have free textbooks. So one of the textbooks I showed is for my anatomy physiology classes, published by a company called OpenStax. They make textbooks for free for most of the most common disciplines. So you can get intro bio, physics, economics, calculus, whatever. So you can have free coursework materials to give your students there. So if you want them to read it, you have a free textbook to read. Types of online assignments, so it depends on the university, but most universities have some type of what we call learning management system. So we have one called Canvas, there's one called Moodle, Blackboard, and these are part of the normal classroom activities at that university. So you can create your quizzes and things online if the students are doing them on campus, for example, with the internet there. And that's also another way to do free type of assessments that's not requiring them to buy some company's package, which the one I used was Mastering Biology, and we do ask students to pay for that. We are able to help with relief though, if students aren't able to afford it, we could give them free access, but you can do that with your own university system and make these assignments for free. And then with the issue that was brought up a couple times about lack of internet completely, you can just have assignments done on pencil and paper. You know, they turn them in when they come into class, and then they do a weekly homework set written on pencil and paper. So there's ways to work around that. For sure. We have a big issue with that in the United States as well. We have a community college system in the United States, which are smaller schools in smaller towns. Most students there are either working full-time, have families, have crazy schedules, are low-income students, and those universities have special challenges, and oftentimes they implement some of these methods that I'm mentioning. So yeah, definitely possible. You sometimes might have to be a little bit more creative, but a lot of the stuff I've been using now, I use the free, I make it myself, I do it for free, and I don't have the data, I haven't assessed it properly yet, but it does seem to be working so far with even the free resources. Great point, thank you. Yeah.
Thank you, yes. I think your talk is really encouraging for us.
Thank you.
And I want to know, how often you show your students how they are doing in the course, because you have the real-time evaluations.
Yep. Yeah, so the kind of real-time evaluations, like in the middle of the class, like the poll everywhere question you did where you clicked in A, B, C, D, or E, it depends on how they answer is whether I show it or not. So the greatest thing when you do the real-time feedback with the phone or the clicker device or whatever is, as the instructor, right, you can see up at your screen or the podium what they're answering. So if you ask a question and 95% get it right, you can just show them that, oh, great job everyone, 95% got it right, move on. But the best thing that happens with those types of questions is when you get half wrong, half right. You get a mix of answers. So then you don't show them the answers yet. You say, okay, now talk to each other and vote again. And usually it goes toward the right answer. Not always, but usually. So it's a way that it's called peer learning or peer instruction. They're going to help each other learn that. And that way then you can show them the first time, look, here, you guys are pretty split. But the second time, now 90% got it right. Good job, you taught each other, you don't need me. Right? So that's a great way to do it. So I show them that data all the time. And then with all these pre-class assignments, weekly homeworks, whatever, they get those scores usually immediately as soon as they're done. So they're getting constant feedback and in terms of their performance on all these items. I usually structure my classes, it's about 20 to 25% is this other stuff. So that's the clicker, participation, the pre-class work, the homework assignments, and then the other 75% or so are the bigger exams. So there's a significant part of the grade for doing all this extra work, right? It helps them with their grade, but it helps them learn is more importantly. And that could help them do better on those bigger exams, which of course then they get the feedback on those when those come around too. Yeah, but constant feedback, immediate feedback has been shown to be very helpful in promoting student learning. Yeah.
I like this approach very much because it involves students deeply into the activity of learning. But I have some sort of suspicion about how much they can think outside the box, because you have an expectation because you have a curriculum and so on, but how much can you let them think outside the box, outside the guidelines, for example?
Great, yeah, so great question about that, about getting them to apply their knowledge, think outside the box, right? So the way with this structure of teaching, again, if you have the content delivery or the content acquisition happening before class, so they're reading the book or they're watching videos or whatever, now you come into the classroom with some basic knowledge. And I don't have to be the one telling you or giving you that basic knowledge, right? So now I have a lot more time in class to do more stuff, to get you to think outside the box. So I have time to have you look at figures from data from journal articles and analyze it. I have time for you to design experiments in groups and try to test the hypotheses. I have time to show you the effects of a new drug on a certain cancer cell and how it affects that, and you have to draw conclusions from it, right? But if I only have the time in class to deliver the content, we wouldn't get the time then to think outside the box. So I think the way the structure is set up of these courses is such that, again, it actually promotes that thinking outside the box. Yes, we are guiding them in getting the basic content, where some people like to say we're holding their hands and we're helping you get through the basic content. But that's okay to me, because I think the goal of higher education is for you to think outside the box, for you to critically think, to solve problems, to think in new ways. And that the time that I have with them in class, I feel is more effective doing that than delivering the content. I like to say I need to justify my paycheck, and in class we have to be doing something that's more than just the content delivery, therefore the thinking outside the box stuff. And I can't do that unless they get a foundation before class by me giving them that structure. Yeah, great point though, yeah. Yeah, yes sir, all done?
I wanted to know if,
yeah. Oh, yeah.
Can you say
someone, yeah.
If you could comment on the differences by different subjects. It looked like in some of the graphs that you presented, the changes were bigger, for example, in physical sciences compared to other subjects.
Yeah.
Are there any studies on that, and why?
Great.
Is that so?
Oh yeah, so that was the comment in question was about that meta-analysis I showed earlier, showing the kind of different colored hedges G or effect size, and some were bigger than others, right? The way that analysis was done is they took any paper that did any kind of active learning. So that could have been clickers, using clickers in class. It could have been having students talk to each other and write a short paper. It could be anything. And so because of the techniques that were studied in that bigger analysis were so varied, it's really hard to say if physics is better with active learning than biology, right? Because, so actually the author of that paper, Scott Freeman, who's at the University of Washington, Seattle, he's doing a follow-up to that one where he's trying to be much more precise now and looking at specific active learning techniques in certain disciplines and then making those comparisons. So the data is still out to say whether one field benefits more than the other. I like to think, based on the overall summary there from that preliminary analysis, that it works no matter what kind of field you look at. There probably are certain disciplines that it's better at than others. I think disciplines like physics and engineering actually can benefit a little bit more because there's so much problem solving inherent to those disciplines, calculations, things like that. Whereas biology, I feel like you have to be a lot more creative to come up with the active learning activities because it's often more about content and concepts. But to say if one is, so it might be easier to use one in the discipline for the other, but I don't know yet if there's more benefits in one discipline versus the other.
And related to that, have you, in the courses that you were teaching, have you done that, for example, in the thermodynamics course compared to the biological sciences and
Oh, for the survey data there? Yeah, so yeah, I didn't have it on there. It's a really good point. So just because I've only been at Mines a little over a year now, I don't have a lot of that survey data. But when I did, and that was the bar graph that I had you vote on, and you saw for the biology students, it was very high for the reading guides. It did look a little bit different for the engineering courses. So for thermo, it actually was more heavily weighted towards me, the in-class lessons. And I think the reason for that is because of the way we assess a thermo course versus an intro-bio course. Thermodynamics, we largely assess your problem-solving ability. Can you translate a word problem to a picture and then apply thermodynamic principles to come up with a quantitative answer, which we do that all the time in class. We model that all the time. However, the reading guide is really just getting you the basic content, and there's not as much of that in a thermo course or a balances course than there is in a bio course. So the students valued the actual problem-solving exercises, which we do very actively in class. I don't just solve the whole problem for them. I give them a few minutes to set it up, then I show them how I set it up. Then they work a few more minutes on the first part, then I show them how I do it. Right? We go back and forth in an active way. But they value that experience more than the reading guide, because again, the nature of the courses are different in that respect. So at first I'm like, oh, that sucks. But then I thought, well, no, that makes sense, right? So you always have to, just like any of your scientific data, you have to look at it critically and think, oh, does that make sense or not? And in this case, I think it does. Thank you. Yeah. Okay. All right.
Well, so we have no more time, so let's thank Dr. Shaffer.
Thank you guys.